Hello everyone, welcome to Distinction Learning Platform. In this video, I'm going to solve some examination questions from ECZ Mathematics Paper 1 in the year 2024. So these two questions, they're covering both grade 12 as well as GCE. Okay, so let us begin. We have the first question saying a container of cooking oil has a mass of 15.4 kg. Find the tolerance of the mass of the container of cooking oil. Okay, so we'll start with the first one. Okay, where we are supposed to find the tolerance. Okay, tolerance. Great. So before we can be able to solve the tolerance, first we are supposed to understand what it means when we say tolerance. So the tolerance, basically, there are so many ways on how one would define it, but in this case or other scenario, I would define tolerance as the difference between the upper limit and the lower limit. Therefore, the difference, basically, what should come into your mind is a minus. So tolerance is nothing but equal to the upper limit minus the lower limit. Okay? Remember, we did look at how one can be able to find the tolerance in that other video, our previous video, okay, where we said for one to be able to find the upper limit, basically you're supposed to say upper limit is nothing but equal to, okay, the upper limit is nothing but equal to the true value plus the absolute error. Similarly, for the lower limit is nothing but equal to true value minus the absolute error. Okay, so the first thing for us to be able to find the upper limit, first we are supposed to find the what? The absolute error. Remember, we have been given, okay, which is 15.4 kg. So this 15.4 kg, okay, if you remember, when finding the absolute error is basically the half of the least unit of measure. Half of the least unit of what? Measure. How do we find this least unit of measure? The least unit of measure, you are also supposed to take note of that it is also known as the tolerance. Okay? In other words, the other name for the tolerance is also known as the least unit of measure. Least unit of measure. Okay? So we said the least unit of measure, if you have been given a number, in this case, the number that we are dealing with is this 15.4 kg. And basically this number, it has got what? One decimal number. In this case, it's a 4. 15, okay? In this case, it's a what? It's a 4. So the least unit of measure for such a number is, we say 0.1, okay? But if say suppose this number was a raw number, the least unit of measure would have been, it's a 1. For example, I have 2, 5, I can have any, so long as it's a raw number, it can be 500, it can be 200, it can be 275. The least unit of measure is always what? 1, like that. Okay? Good. So, to find the absolute error, we know to say absolute error, okay, is basically half multiplied by the least unit of measure. But the least unit of measure in this case is the what? The tolerance, isn't it? Great. It is the what? The tolerance. So according to the question here, we can even find the answer minus doing the computations or rather the calculations. If you look at this number, okay, we are saying this number, it has got what? 1 decimal place. Therefore, the tolerance is what? 0.5. So, you know, this topic, it is very simple in that one can be able to, you know, to tell the answers, okay, minus doing the calculations, okay. So in this case, okay, the answer here is 0.1. Now, how are we going to show that the answer is 0.1? We can use this formula. So first, we have to find the absolute error. So the absolute error basically is half multiplied by the what? The tolerance. So the tolerance is 0.1, like that, isn't it? So if I were to multiply, this is 0.5 multiplied by that, I'll get 0.05, okay, kg. So basically, this is the absolute error. Now, for me to find the upper limit, I'll say true value plus the what? Absolute error. My true value is what I've been given. In this case, it is 15.4 kg. Okay, cute. So now, I will say, okay, my upper limit is basically what I've been given. The true value is 15.4 plus, you know, 0.05. Okay, so if I add this, I'm going to get, this is okay, this is 4 point, this is 15.4. Similarly, for the lower limit, which is the, you know, the true value is that minus 0.05, like that. Okay, so I'm subtracting. If I have 15.4 minus 0.05, this is 0, like that. This is okay. So this by that, I'll get a 1 from 4. I'll remove 3. This becomes 10. That by that, I'll have 5. 3 minus 0, I'll have 3 point. This is basically what? 15. So I'm getting 15.35, like that. Okay. So remember, I want to find the tolerance. Okay. So the tolerance in this case is the upper limit is what? 15. Okay. 0.45 kg minus the lower limit, which is 15.35 kg, like that. Then what am I going to get? This is 0. This is 1. Okay. 4 minus 3 is 1. 0.15 minus this is 0. Therefore, the tolerance is basically 0.1. Good. Okay. So this is very simple in that one would know to say, okay, the tolerance, the answer is this. Now it's just a matter of showing the way. Okay. Or if you don't want to, you know, to use this formula, you can just basically say tolerance. Remember, we did this. Tolerance is basically 2 multiplied by the what? Absolute what? The absolute error. So 2 multiplied by the absolute error is basically what? 0.05, like that. And if you multiply 2 by that, you should be able to get 0.1. That's how you can be able to find the what? The tolerance. So this is very simple. Okay. Now let us solve B. Write down the relative error of the mass of the what? The container of cooking oil as a fraction in its what? Simplest form. So we have to find the relative error. Okay, you have to find the relative error. Okay, you have to find the relative error. Okay, so before we can be able to find the relative error, okay, you must be able to recall that by definition, the relative error is basically the ratio between the absolute error and the true value or the measured value. Okay, so the ratio, when we talk about a ratio, basically what should come into your mind is that we are talking about division. Therefore, relative error, okay, is nothing but equal to the absolute error divided by the what? Okay, so absolute error divided by the what? The true value or the measured value. True value, like that. Cute. So the absolute error we found, okay, we had found, which is 0.05, like that. Why 0.05? Because this number, okay, our number, which is 15.4 kg, it has got 1 decimal place, okay. If, say, suppose it was a number, our absolute error, okay, if so it was a whole number, our absolute error would have been a 0.5, okay. But since it has got 1 decimal number, so in this case it's 0.05. If it has got, let's say 2.5, maybe 6, 2 decimal numbers, this would have been 0.05. Cute. So now our true value is 15.4, like that, and basically this is nothing but equal to. So when you reach here, since this is step 1, and in most cases we let me say you are not allowed to use a calculator, okay. So there are some small concepts, okay, or rather I would call them skills that we use when solving, okay. So if you recall very well, during your time when you are in grade grade 2, grade 3, somewhere, where we looked at how one can be able to converting decimal numbers to proper fractions, okay, to proper fractions. It can be improper fractions, it can be proper fraction. So basically, if I have 0.05, okay, so if I want to convert this, basically we were doing it like this, where there is a point to put 1, this becomes zeros. Whatever that you have, the numbers after the what, they become zeros. That's how we are doing it. But in this case, since I want to make sure that I want to let go of this point, instead of dividing, okay, because basically this is the same as this point will disappear, then 5 out of what? 100, and basically this is the same as 0.05. But in this case, I want to make sure that this point disappears, okay. I'm trying by all means to avoid working with points. So what can I do? I can multiply this, okay, by 100, even downwards by what? 100. And basically this means that I haven't changed anything. What do I mean? 100 into 100 is just the 1, meaning I will remain with what I had in the first place, like that. So if I multiply this by 100, meaning this point should what? Move how many? 2 times, like this. 1, 2. And why did I multiply by 100? Because here, if I count, then the numbers which are after this point, they were 2. So I had to multiply by 100. But if, say, suppose the numbers after the point, maybe if I add 0.5 out of, say, maybe 2.5. So this is, there is just 1 decimal number. So here I can't multiply through by 100, but rather I have to multiply by 10, like that. Why? Because I only have 1 number, which is a decimal number. So in this case, you multiply through by 100. Hopefully that's clear. So now, if I multiply this by that, this point has moved 5 out of. I'm multiplying this, okay? So this point to move how many? 2 times, okay? 1, 2. So there remains the 0. There is where the point is. I'll have 15, 4, 0, like that, okay? Then I'm dividing now. This is very simple now. 5 into 5 is 1. 5 into 15 is what? It's a 3, like that, okay? 5, okay, into 4. It can't. Okay, 5 can't go into 4, but rather I'll write the 0, okay? It's 0. Remainder 4, okay? Then here, 5 into 4, again, it can't go, so I'll add the 0. This becomes 40. 5 into 40, this becomes 8. Therefore, the answer is 1 out of what? 308 as my relative what? Relative error. So I've solved this one. Write down the relative error of the mass of the what? The container of cooking oil as a fraction in its simplest what? Form. So this is how you're supposed to do it. Okay. Now let us look at the second question. The length of a sugarcane is measured as 2.6 meters. If its true length is 2.5 meters, find the absolute error. Good. What a, good question. Okay? What a good question. Okay. What good question. Good. So the first question is saying find the absolute error. When you're finding this absolute error, okay, it's very, very important, okay, because when you want to find the tolerance, it will involve finding the absolute error. If you want to find the relative error, you want to find the percentage error, it's very important for you to know how to find this absolute error. Okay, so now, how do you find the absolute error? Looking at this scenario, or rather the case. So we have two values. There is a measured value, okay? Measured value, which is basically 2.6 meters, like that. And we have the true length or true value or true length, okay? Doesn't matter, which is what? 2.5 meters, like that. And I want to find the absolute error. Remember, in the other video, we looked at two important definitions for the what? The absolute error. Okay? So in this case, the definition that we are going to use is the second one, which stipulates to say the absolute error is basically the difference between the measured value and the true value. Therefore, absolute error is nothing but equal to modulus of measured value minus the true value or the true length, like that. We can, plug in. The measured value is 2.6 meters minus the true value is 2.5, like that. And what are we going to get? 2.5, okay? Minus that, we are going to get, this is 0.1, like that. And the modulus of 0.1 is a positive. The answer is always what? A positive, like that. So the absolute error is 0.1. Good. Now, so we've solved this, and you should be able to get your 2 marks. Next, we want to solve the percentage what? Error. Remember, from the definition of a percentage error by definition is the relative error, which is expressed as a what? A percentage. Great. So percentage error is equal to the what? Relative error, which is expressed as a what? Which is expressed as a what? Percentage, like that. So relative error, we know to say is a what? Absolute what? Absolute error divided by the what? The true what? True value multiplied by 100 what? 100%, like that. Therefore, our absolute error we found, which is 0.1 divided by the true value we check from the question. The true value, which is basically the true, the true length. So here the true value, or rather the true length is 2.5, like that. Okay, so I want to make sure that I avoid working with what? Points. How am I going to do it? So I will look at the number. This is 0.1. I will look at what I have here. I want to let go of this point. What number am I supposed to multiply here? Okay? So since I have one decimal number, I can multiply by 10. If suppose there were 2, I would have multiplied by 100. If there were 3, by 1,000, like that. So I'll multiply this by 10, like that. Even this one, I'll multiply it by what? By 10. Remember, I haven't changed anything. When whatever number that you multiply on the numerator should also be multiplied under the what? On the denominator. So what am I going to get? This by that. This is basically this point will move. This becomes 1 out of this is this point will move. This becomes 20 what? 25. But remember, there is a percentage. Okay? There is a what? A percentage. Okay. There is a percentage. Okay. So 100%, like that. Okay. I know to say this is the 25, okay? So this 25, it can go into 100, isn't it? How many times? 4 times. So 25 into that, I'll have, it's a 4% like that. Okay? Yes. As the way they would solve this one, they would say the absolute error, okay, is 0.1 divided by the true value is 2.5 multiplied by 100%, like that. And that's how they would do it. So this is 100, I'll say over 1. This is what? 100. So the point to move how many? 2 times. 1, 2. There becomes 0. This becomes 10 out of 2.5. Remember, there is a percentage we are solving. So this is basically the same as, okay, 10 divided by what? 2.5. Remember, you're not supposed to use a calculator. This is 10 out of 1. This will change. Okay? So now, if this is 2.5, now you want to change it to a what? A fraction. It can be proper or an improper. So there is a point you are supposed to put 1. Whatever decimal number is 0. This becomes 25 out of 10. So here, this is 25 out of 10. Okay? So if I multiply this, what happens? This will come on top. This will become what? Below. So this, what happens? The denominator on top, the numerator becomes on what? Because it becomes below. Becomes the, the denominator. So over 1. This like that. So if I want from here, instead of multiplying, I would have said 5 into 5 is 5. 5 into that is 2. 5 there is 1. 5 into 10, that is also 2. 2 times 2, which is 4%. Okay, so the guys, there are so many ways one would, use, okay, to solve such a question. Yeah. So, thank you for watching this video. Okay, share and don't forget to leave a like button. Thank you.